You ever take a sip of coffee and wonder, is this too hot or are my hands just cold? We do it all the time. We trust our sense of touch. But how trustworthy is it really? Let's dive into the science of temperature, how we actually measure it, and why a specific number is so much more powerful than just a feeling.
You know, the physicist Anna Mani really just nailed it with this quote, and it's the core idea for our whole explainer today. When you think about it from our own health to the planet's climate, a bad measurement can be way more dangerous than not having one at all. Accuracy. It's everything.
I mean, we've all done this, right? Someone in your family feels sick, and what's the first move? The back of the hand on the forehead test. So in this story, a sister, Favon, feels her brother Lambuk's forehead and she's totally convinced he has a fever. But just to be sure, she grabs a thermometer and it shows a completely normal temperature. So, who's right? The hand or the device?
This is that classic showdown, isn't it? Our gut instinct versus a scientific tool, and it really forces us to ask this fundamental question. When it comes to temperature, can we actually trust what our own body is telling us?
Okay, let's put this to the test. There's a brilliant and super simple experiment you can even try at home. And this is going to show you firsthand just how misleading your sense of touch can be.
The setup couldn't be easier. You just need 3 bowls. On the left, fill one with some ice-cold water. On the right, one with warm water. Now stick your left hand in the cold one and your right hand in the warm one, and just let them sit there for about a minute. What you're doing is you're teaching each hand to get used to a totally different temperature.
All right, here comes the wild part. You're going to take both hands out at the exact same time and plunge them right into that middle bowl of plain old top water. Now, just for a second, what do you think you're going to feel? It's the same water, so both hands should feel the same temperature, right?
Wrong. Prepare for your brain to get very, very confused. The hand that was just in the warm water is going to tell your brain the tap water feels cold. But the hand from the ice water is going to swear that the exact same tap water feels warm. Your brain is getting 2 totally opposite signals from the same source. I mean, how is that even possible?
And that little trick just lays it all out there. Our sense of touch is completely relative. It doesn't measure the actual temperature of something, it just tells you the difference between what you're touching now and what you were touching a second ago. It proves that if we want a reliable measurement, we have to take our own feelings right out of the equation.
So if our own hands can lie to us, what can we trust? Well, this is where science steps in and gives us a tool to get an objective answer, a way to measure how hot or cold something truly is, no matter how we feel.
What we really need is a standard, right? Something that's reliable, something that doesn't care if you were just holding a snowball or a hot mug of tea. We need an impartial judge. And that reliable measure has a name: temperature. See, it's not a feeling, it's a number. It's a quantifiable property of an object. A hotter object has a higher temperature than a colder one. It's as simple as that. And it gives us a way to compare things objectively.
And the tool that lets us get that number is, of course, the thermometer. That's the device that translates the physical property of hotness or coldness into a number that we can all read and, more importantly, all agree on.
But you know, it's not quite as simple as just grabbing any old thermometer. It turns out they're not all created equal. Depending on what you're measuring, your own body, a chemical in a lab, the air outside, you're going to need the right tool for the job. So let's look at the 2 most common types you'll run into: clinical and laboratory. A clinical thermometer, that's the one you use when you think you have a fever. It's designed for one job and one job only: measuring human body temperature. That's why its range is so narrow, usually just 35 to 42 degrees Celsius. But a lab thermometer, that's the workhorse. It has to be ready for anything, so it measures a much, much wider range, often from below freezing at -10 all the way past boiling to 110 degrees Celsius. Okay, so we've got the right tool. We get a number, but what does that number even mean? Think of it like a language. To communicate the idea of temperature, we all have to agree on which scale or which language we're speaking. And there are 3 main players on the field: Celsius, Fahrenheit, and Kelvin. Most of the world uses Celsius. It's super logical. Water freezes at 0 and boils at 100. The US mostly hangs on to Fahrenheit. And then there's Kelvin. Scientists are huge fans of Kelvin because its 0 point is absolute zero, the coldest anything can possibly get in the universe. It's the official scientific standard. So just for context, a normal body temperature is about 37 degrees Celsius or 98.6 degrees Fahrenheit. So we have the tools and we know the language, but none of that matters if we don't use them correctly. Let's circle back to what Anna Mani said. A wrong measurement is worse than none at all. So let's make sure we get it right.
Okay, for a digital clinical thermometer, the process is pretty straightforward. First, and this is important, always wash the tip with soap and water. Then, you place it under your tongue, you wait for that little beep or the light to flash, and then you just take it out and read the temperature on the display. Simple as that.
But there are a few key things to remember. Always wash the tip before and after you use it. Be really careful to keep the digital display part out of the water, and try not to hold the thermometer by its tip because the heat from your own fingers can actually mess with the reading.
Now, let's switch gears. We're going from the first aid kit to the science lab. If you're using one of those long glass laboratory thermometers to measure a liquid, the rules completely change. Getting an accurate reading here takes a whole different set of skills.
Okay, look at this. This right here is the #1 mistake people make. The correct way, on the left, shows the thermometer held straight up and down, with the bulb totally surrounded by the liquid, but without touching the bottom or the sides of the beaker. Why? Because if you do what's on the right and rest the bulb on the glass, you're not measuring the liquid's temperature anymore. You're measuring the beaker's temperature. Big difference.
And this is probably the single biggest difference from using a clinical one. See, a clinical thermometer is designed to lock in the highest temperature it reads. A lab thermometer, it doesn't do that. The second you pull it out of the liquid, that reading is going to start to drop. So you have to remember this. You must read the temperature while the bulb is still in whatever you're measuring.
So temperature is so much more than just a feeling. It's a precise scientific number. We've seen how our own senses can completely fool us, and we've learned how to use the right tools the right way to find the objective truth. So I'll leave you with this question. Now that you have the power to measure it accurately, what part of the world around you are you going to choose to understand just a little bit better?